medium vibrates perpendicular to the direction of propagation. And we are going to produce the transverse waves by using this device. This is called as string vibrator. It can vibrate. We know the vibration. How can you make the string vibrator to operate? By sending the AC signal. This is a AC signal generator. It can produce alternative current of different frequency and different amplitude. And you are sending the AC signal of a particular frequency and amplitude to the string vibrator. It's made up of quartz crystal. The quartz crystal vibrates. It shows the piezoelectric effect. And the AC signal is converted to vibration. And the frequency of vibration is equal to the frequency of AC signal we have sent. Now, this vibration make the string to vibrate. And the standing transverse wave is allowed to travel in this direction. And you know the wave speed depends on the tension and the linear density. Right? The tension and linear density. What you are going to find here that determine the speed of the wave you are going to find. There are two different methods we did. You know the wave speed depends on the linear density of the rope, of the medium, and the tension. How can you make the tension? The tension can be maintained at any level. According to the information, you can make the tension. The tension is nothing but the load added to this. How much load added? Is there any information? Load added. Okay. Load. 0.2 kilogram. 200. Okay. Let me take 200 kilogram. As per the instruction, you have to add. If it's 200, add 200. If it is 150, add 150. Now in the class we added 200. 200 gram mass is added. The tension on the rope is equal to m into g. The tension along the rope is equal to m into g. The speed of the wave is decided by the two factors. One is the linear density. Linear density is equal to mu over L. Mu equal to m over L. The m is the mass. The mass of the rope will be given. The length, you can measure the length of the rope, right? The length of the rope starts from here. By using the tape measure or the ruler, you can measure. And mu equal to m over L. You can calculate the linear density. And the tension equal to m into g, right? Now, you are going to produce a standing wave. The wave is traveling, transverse wave traveling up to this. It travel up to this point, it gets stopped because the rope is attached to the pulley. The wave cannot travel further. The wave stopped and return back. Now, original wave and the reflected wave, they are meeting with each other. It's a superposition of the wave. And due to the superposition principle states that the resultant wave, resultant wave amplitude may be maximum or minimum. If it is maximum, and that point is called as antinode. It's a minimum, is called as node. Now, the node and antinode will not be produced for all frequencies. When the frequency of the wave is a particular value, resonant frequency, then only you can produce well-developed loops. And if you form the well-developed loops, that means the frequency is equal to resonant frequency. The resonant frequency you can classify into many nodes. If the frequency required to produce only one loop is called as first harmonic, N1. And frequency required to produce two loops is called as second harmonic, third harmonic, fourth harmonic, and so on. Right? Now let us come to this. The mass in the wire. The mass of the wire, I will give you the mass of the wire. And the length of the wire, you can measure it. You can calculate the mu. Mu is equal to mass over length. I am coming to the first part, that is the second schedule. You are going to fix the load, that is 0.2 kilogram, that means 200 gram. And the acceleration due to gravity, you know it, 9 into g. You can calculate the tension. Tension is equal to m into g. You got the tension of the rope. And then the mass per unit, that is the linear density. In the previous page, you calculate the linear density, carry this here. Now, what is the velocity of the velocity of the sound on the rope? V equal to tau over mu square root. V tau is this, mu is this. Can you calculate the velocity? You got the velocity. Now coming to this, you are going to adjust the frequency for different nodes, the different loops. Loop 3, 4, 5, 6. How many loops are given? You have to produce that many number of loops and find the frequency. You know the relation between length and the resonance wavelength. Lambda n equal to 2L by n. And L is the length of the rope. What is n? N is a harmonic number. This is n. If it is 3, can you substitute 2L over 3? 2L, 2 into L over 3, you can find the lambda 3. And lambda 4, lambda 5, whatever the things you want, you can. How can you find this? Lambda n equal to 2L by n. L is the length of the rope, n equal to the harmonic number, 1, 2, 3, whatever the number, you can use it. And 1 over lambda n, you can find the reciprocal of this. Now this is the frequency at which this number of loops are formed. First, how many loops are you producing? 3 loops. How can you produce this? You have to adjust the frequency.
We are increasing the frequency? Or
Increase or decrease, I want to get particular number of loops. How many loops?
4.
Then you adjust this one. You will get 4 well-defined loops. Right? 4.
Yes.
If n equal to 4, what is the Fn? This frequency. If n equal to 3, then reduce this. Now this is the frequency for n equal to 3. You can write Fn and 1 over lambda n. Then you can draw the graph between graph between what? Slope of the graph 2. They are asking to draw the graph. Yes. The graph 1, plot Fn versus 1 over lambda n. This is graph 1. This is Fn. What is the unit? Hertz. You can take some values, right? You know how to calculate it. This is 1 over lambda n. You will get a straight line. Now, can I get the slope? The slope of the graph, you can select any 2 points. This is y1, x1, x2, y2. y2 slope 1, y2 minus y1, x2 minus x1. You will get some number. What is the unit? Hertz. Hertz divided by 1 over meter, right? 1 over meter. 1 over meter. How to get it? This Hertz is nothing equal to 1 over second. 1 over meter is equal to meter over second. Is that right? It will go there, it will come down. Now you got the slope. The slope is equal to, the meaning of the slope is equal to Fn by 1 over lambda n. Can I say your slope is equal to Fn lambda n? Is that right?
Yes.
Fn lambda n. Now the speed of the wave is equal to F lambda. So your speed is equal to slope of the meter per second. You got the speed from the slope of the graph. There is no calculation. Just get the slope. The slope is equal to the speed of the wave. Clear?
Yes, sir.
This is the big change. If you rotate this,